So now in this video, we're going to look at an inductor really quick. So I have one here in my LCR meter. We will turn the power on and it will automatically test it. And you can see that it is a 10 millihenry. So that would be the same as a 10,000 microhenry inductor. So they're fairly large. I didn't pay a lot for them. I think I got them from eBay, and they came 20 of them. And so in any case, 10 millihenry. We can also look at, try to keep the glare off, the capacitance of it. So they do kind of build up charge across them, as there's a frequency going across them. It's 1 kilohertz right now, and there is some resistance to this. It's not resistance free, about 25 ohms of resistance. So in any case, we have a 220 ohm resistor also providing resistance. So let's zoom in and look at this a little bit closer. So we're going to need to turn the light off. So the inductor though here, 10 millihenry inductor, is in parallel with those two LEDs, and the LEDs are facing in opposite direction. They're a polarity indicator, and when I hit the switch, you can see the blue LED briefly flashed, then it went out. We have a steady current. As I hold the switch down, I release the switch, the green LED briefly flashes, and current technically stopped when the green LED flashed. The current, as far as the power supply is concerned, the current to flash the LED came from the inductor. And so when I press the button, the blue one flashes. When I release, the green one flashes. And you may have saw them both light up at the same time. That's because the switch did not quite make a contact, made a contact and lost that contact right away. And so they both look like they flashed at the same time right there. And so let's take this apart and put it together and talk a little bit more about what is going on. So I'll pluck the inductor and the LEDs. So we have the switch right there, and so of course that makes it so when we're not pressing the button, there's no connection between the top and the bottom. Top is always connected to each other, bottom is always connected to each other. And then so we'll grab a resistor here, 220 ohm resistor. When we close the switch, that will limit current. Not sure the best spot to put this, but we want it 2 spots away from that jumper right there. It doesn't really want to go in to these spots right now for some reason. There you go. So 2 spots away from the jumper down there. That's because these pins here are 2 spots away for the inductor. Now, it doesn't matter which color we do. We were doing blue lighting up when we press the button. So we'll take the blue LED, and I really don't like where the resistor is at the moment. Let's slide it over. So the blue LED, we want the long lead, the anode, to the resistor. Short lead, the cathode, we want down 1, or actually 2 rows now, to the negative jumper. So when we press the button now, the LED will light up. And you notice the LED stays lit up. And also, there's less current. That's because we're dealing with 5 volts. The blue LED is blocking 3 of those volts. So we have less than less than half of the current, because the LED is blocking most of the voltage. So now, the long lead, the anode, is to the resistor. So for this LED, we want in the opposite direction, and this actually provides some protection. So long lead, the anode, to the negative rail, and the short lead, the cathode, is going to go up to where the resistor is, and the other side of the blue resistor right there. So they're in opposite directions. So now again, without the inductor, we hit the button, the blue LED turns on, the blue LED, well, it stays on, I release the button, nothing happens with the green LED. Even if we turn the light down, it doesn't flash or anything. What was causing it to flash was the inductor. So we take the inductor, and what the inductor does is it does not quickly change how much current is flowing through it. So we're going to go to the resistor and then to the jumper. So when I hit the switch, voltage builds up across the inductor instantly, but current does not flow through it instantly. Whereas voltage builds up across the blue LED and current does once it is at least about 3 volts approximately. Both of the blue and the green LEDs are about 3 volts forward voltage, whereas the red and I think it's the orange or the yellow, whatever it is, they're closer to 2. But in any case, we get the voltage, and instantly the LED starts conducting. It keeps the voltage also below 3 volts as far as the inductor is concerned. But the inductor starts conducting, and then current flows through it steadily. So as current starts flowing through it steadily, the voltage drops for the LED, and the blue LED, turns off. The green LED is reverse biased during this process when we press the button. So only the blue LED briefly flashes and current goes through the inductor. So we will turn the light off. So now when we release the button, the green LED flashes. And zooming back, that may have been hard to see. So press the blue button, or press the button I should say. The blue LED flashes briefly, and then current starts flowing through the inductor. It resisted the current flow at first, but then it starts flowing freely. So it's going around the blue LED because it blocks voltage. So now, when I release the button, that inductor, again, it doesn't want to change the current flow suddenly. It does relatively quickly, but for a moment, it wants to keep the current flowing. So current was flowing this way. We release the switch, current no longer flows that way. It still wants to flow that way through the inductor though, so it goes through the LED because that's the way that it is wired up. That side's more positive, that side's more negative as current flows in a circle until the inductor runs out of energy. So actually it builds up a magnetic field when we press the button. So now it has a magnetic field built up, and when I release the button, the magnetic field collapses, and in that process, forcing the current to go through builds up the magnetic field. So the magnetic field is built up, and then cutting the current flow. That magnetic field is not being pushed out anymore. It collapses, and while it collapses, it keeps the current flowing. So, in any case, I just thought this up, and I did it in the past too, but I thought I would work on inductors a little more while I update the website and whatnot. So hopefully you like this demonstration. Right now it's just a demonstration. I'll do more on it later. So, thanks for watching. Make sure you click subscribe, these other videos that I'm posting, and make sure you click the bell so you get updates. Thanks for watching. I will see you in the next video.